3 points out there that make a triangle, and we don't need to plot them, although you can if you want. I'm just going to draw them. All right, and I want to find angle B. Now we can do that in a couple of different ways. And it makes no difference to me, none. You can do it however you're comfortable doing it. So like the law of cosines would be an option. I'm going to go ahead and do it using vectors because that's the chapter that we're talking about, but you don't have to do it this way. If I do this problem using vectors, what is the first thing I need to do? Get the vectors. And the vectors that produce angle B would be BA and BC. Now, it is important, if you are using this method to find angle B, you must be using BA and BC. Those are the only vectors that will produce angle B. All right, so what are the coordinates of BA from B to A? -2, +6. Yep, we're going from 3 to 1, from -4 to 2. Good. Now, what about B to C? -4, +5. Now, we just did this problem over there. Over there, we found the angle between V and U. Now I'm finding the angle between BA and BC. So what do I need to do? I need the magnitude of both vectors. So the magnitude of this guy would be root 40. And I'm not gonna, I know that simplifies, I'm not going to. It just makes it harder for me to type in. What's the magnitude here? Root 41. What is it? Yeah. Times the cosine of the angle between them. And what's that going to equal over here? What do I have to have on the other side? The dot product. And the dot product of those two vectors would be 38. So I'm going to go ahead and multiply 40 and 41 together. It just makes it easier to type in. I don't need to do that. So 38 over the square root of 1640 is the cosine of B. And I got angle B to be 20.22 degrees. Is that what you got? Someone not shade. Yes? Okay. Now, letter B. Now that you have this information, you have found that BA is root 40 and BC was root 41. Now that you have that information, the next question says, find the area of the triangle. Well, could you do 1/2 root 40 times root 41 times sine 20.22? That's how we find the area of a triangle, so feel free to do that. I showed you something else the other day, which you can take or leave, but you can also find the area by just making a little determinant out of these two vectors you made, and it would be -10 minus -24, so -10 minus -24, so that would be 14 divided by 2. You should have gotten 7 for your area. Would somebody do 1/2 this times sine this? You get 7? So either way is fine. If you have already found this angle, then you can go ahead. 1/2 side side sine is just as easy as anything else. But this is another option for you to find the area. All right, and finally number 12. Write the Cartesian equation for these two parametric equations. Now, by Cartesian equation, we mean an equation that has just x's and y's. This is the Cartesian coordinate plane, is x's and y's. So we need to get rid of the t's. Now, we did this the other day with a problem, maybe that same problem, one that looked a lot like it. How do we begin eliminating the parameter for this equation? What?
We start by dividing.
I do. You don't have to. That's my personal favorite thing to do. I like to divide by the coefficient, so that all I have left over here are my trig functions. You do not have to do that. I like to do that. All right, and then what? Square it. So this is going to become x squared over 9 equals cosine squared. And this is going to become y squared over 16 equals sine squared. And why did I do that? So now I can add them together. The whole purpose was to get rid of the t's. What's going to happen over here when I add these? I get 1. So I have x squared over 9 plus y squared over 16 equals 1. And you recognize that as the equation of an ellipse from last year. That's an ellipse. That's the final answer. Your job was to write it as as one equation, not 2, but 1 with no t's, and that's what we got. All right, now you guys are the lucky ducks. We have pre-quest 1, 2, and 3, but I've only formally assigned 1 and 2. So let's just pick 1 or 2. You can pick, I don't care which one you want to do. Let's go with 1. It looks like it has more problems on it. And remember, I'm doing it for you and it's your homework. So here we go. So you might want to start a new sheet of paper. We're doing pre-quest number 1. This is your homework.
6:1 to 6:30.
Yep.
Thank you.
You will need to turn this one in and number 2, which I will not be doing with you in class. So you have to do that one on your own. Number 3 is optional. So you can do number 3 or not do number 3. I don't care. It just depends how much you want to practice. All right, so here we go. Number 1, find BA. BA. All right, so what are the coordinates of BA? A is 1, 2, and B is -3, 4. So BA is from B to A. +4, -2. All right, number 2. 2V dot U. So this is a dot product. Probably the first thing we ought to do is figure out what 2V is, right? What's 2V? -2, 6. And we're going to dot that with 1, 6. So what would that be? That dot product between 2V and U would be -2 plus 36, which is 34. Please remember that the dot product is just a number. It's one number. Find the measure of the angle between V and U. Oh, we've done this twice already today. We should be good at this. Find the measure of the angle between V and U. So V is -1, 3, and U is 1, 6. Here we go. What do we need to know to find the angle between them? That we need the dot product, so the dot product of these two would be what? 17. And the dot product will equal what? Magnitude of this one, which is? Root 10 times the magnitude of this one, which is? Root 37, times the cosine of the angle between them. So 17 over root 370 is the cosine of theta. Whoop, somehow I messed up. I got 27.9 basically. Anybody want to agree or disagree with that? Agree? All right, number 4. We're going to add VA plus AC. Now, did we already find VA? I think we did. So we're adding 4, -2 to AC. So what is AC? 50? So we're adding those together, so the answer would be all right, number 5. I think we already answered this one in another problem. What's the magnitude of V? Root 10. Yeah, we already answered that one. All right, now we got to find the magnitude of 3V minus U. Now, treat the magnitude symbol, the absolute value symbol, treat that like parentheses. So you want to evaluate this first before you find the magnitude. So what would 3V be? -3,9. And we're going to subtract U. So that will be what? -4, 3. Now that's what you want to find the magnitude of. So we figured out what was in there, and now we're going to find the magnitude. And what is the magnitude of that? 5. All right, so let's see, that was 6, so now we are in 7. Find a unit vector in the same direction as V. All right, this we talked about yesterday. How do you make a vector into a unit vector? That is not a unit vector. You've already told me that guy is root 10 long. His length is root 10. If you're a unit vector, your length is 1. So that's not a unit vector. How do I make it a unit vector? Divide it by its magnitude. So I just divide both of these by root 10. I don't have to rationalize it. That will be the unit vector. We did that yesterday. We also did number 8 yesterday. It says, or this time we're dealing with U, vector U. And we want to find a vector just like U, that moves just like U, but its length is 4. Now, the length of this is not 4. The length of this is what? How long is this? 37. I need that same vector, that same movement, but I need it to be 4 units long instead of root 37 long. So how do I do that? Make it a unit vector first. So the unit vector would be this. Now, how long is this guy? How long is he?
1.
He's 1. How long do I want him to be? So I'll just multiply him by 4. So 4 over root 37, 24 over root 37. That is the vector that is the same direction as the original, but now it is 4 units long. So, how do you change the length of a vector? Well, first you divide it by its magnitude, and that will make the length 1, and then you multiply it by whatever length you want. All right, number 9. Find the direction angle for BC. Well, wait a minute. What are the coordinates for BC? First of all, we need to know, what is BC? 9, negative 2. So if I draw 9, negative 2, that means I come over 9 and down 2. This is the direction angle. So the coordinates of the vector are 9, negative 2, that's BC. And I need its direction angle. Alright, so what am I going to do here? I really can't find this guy, but I can find this one right here. I'll call it X for a minute. And I know that X is the angle whose tangent is 2/9. I'm not putting the negative in there. I need to know how big that angle is. So I'm just going to say it has a tangent of 2/9. It's negative because it's in quadrant 4. So I got about 12.53, if I did that right. If you put the negative in, you got negative 12.53. Now, don't say 12.53. That's in quadrant 1. I need to go all the way around. So how am I going to get the actual direction angle?
350
Minus 360. And I get 347.47 degrees. So my direction angle is 347.47. Alright, that was 9. Let's see, 10. Write CA as a linear combination of I and J. Now, any vector can be written in terms of I and J, but I need to figure out what the vector is first. So I can't remember if I've done CA or not. What are the coordinates of CA?
2.
Okay, so what are the coordinates of the vector from C to A? From C to A, negative 5, 0. So that vector is negative 5, 0. Now what that means is, in moving from C to A, I back up, I take 5 steps back, and 0 steps up. So what is that in terms of I and J? Negative 5i plus 0j. And you don't even have to put the 0j on there, but we usually do, but you don't need to, obviously, since it's 0. Remember, I and j are just vertical and horizontal and vertical steps. So if you're backing up 5, that's negative 5 i's. I is a step, and you're taking negative 5 of them, and no j's. All right, now 11, find a vector parallel to V. I think we've already talked about this today. What is V? Negative 1, 3. So what would be a vector? And there are infinitely many answers. There are trillions, zillion, billions of them. What would be one possible vector parallel to this one? Negative 2, 6. How do we find parallel vectors? We just take a multiple, any multiple, except 0, don't times by 0. All right, now I want one orthogonal. Remember that vector word, orthogonal to U. So here's U, and I want to be orthogonal to it. Okay, so can you think of a vector that would be orthogonal, perpendicular, to vector U? Negative 6, 1, somebody said? What's this slope? How does this vector move? Over 1 up 6. That's a slope of 6 over 1. What's this one?
Negative.
1 over negative 6. Are these perpendicular to each other? They sure are. Now there are infinitely many answers. Infinitely many. But that is a real simple one. Alright, so that was 12. 13, find the components. All these problems look so familiar. Find the components of the vector. And the vector has a magnitude of 7 and a direction angle of 55. Alright, how do we do this? What do we do? What am I looking for? X and Y. How can I find X and Y? Sine 55 equals Y over 7. So Y equals 7 sine 55. And X is going to be exactly the same thing, except X is cosine. So 7 sine 55. So you're looking for components. So Y is 5.730. And X is 4.02. Alright. Number 14, find the work, and all these problems are the same. We've already done these. Find the work when a 10-pound force in the direction 2, 3 moves an object from 0, 0 to 6, 0. So here I am pushing my chair from 0, 0 to 6, 0. The direction of my arm is over 2, up 3, and I'm exerting 10 pounds of force. So, work. Force times distance times cosine of angle between them. So here we go. What do I know? I know the force is 10. What else do I know? The distance is 6. Now, I wish I knew the angle. All I know is that this force is acting in the direction over 2, up 3. I need to know this angle, and I don't. Can I find that angle? Yes. And how would I do that? Second tangent, 3/2. So that angle is actually 56 point something. So now I'll take the cosine of that answer, multiply it by 6 and 10, and I got an answer of 33.28 foot-pounds. Oh my gosh, look at number 15. We already did this one too. This one's going to be a little bit different than the last one because these numbers match. So if you like, I mean, I'm kind of programming you to do it the way I do it. You don't have to divide. I like to divide because I know then what I'm going to do next is what? Square. And when I square these things, then I'm going to add them, right? And what's going to happen over here? If all I have over here is cosine squared and sine squared, that's going to always make 1. And then over here, I'm going to have x squared over 25 plus y squared over 25 equal to 1. Now that is absolutely fine, but since these numbers match, sometimes we go ahead and multiply through. You do not have to do this, but then it looks like the equation of a circle. This is a circle, since those two numbers are the same. It's not an ellipse like the other one was. This one is a circle. I was hoping we'd get something new and exciting. This is not new. This is writing the equations, parametric equations. So we know what that means. Write the parametric equations for the line through -2, 3, and 1, 5. So we need the slope, for sure. You can do this in whatever order you want, but you definitely need the slope. So 5 minus 3 over 1 minus -2, I got 2/3 for my slope. Double check that. What do I do with that? What do I do with that? Those are the coefficients on t, and you know what's going to happen. Kids are going to get them in the wrong order. Pay attention. Slope is y over x, so we're going to put the 2 here and the 3 here. All right, and then what goes in the other blanks? Pick a point, so you can use -2, 3, or you could use 1, 5. It doesn't make any difference. I know they look different, but when you start graphing it, you'll end up with exactly the same points. Exactly. All right. Number 17. Sketch on our calculator. So x equals 4 cosine squared. Now remember, if you're typing that into your calculator, you're going to have to type it in like this. And y equals 3 sine. So first they want me to graph it. Then I'm going to write a Cartesian equation for it. First I'm going to graph it. So make sure you're in parametric mode, right? You're putting in parametric equations. So you need to be in parametric mode. Let me check my window. It's still set from the other day, so it's good. If you are in degrees, as I am, you'll want t to go from 0 to 360. And I'm going to type in my equations. What you get? If you do this on your calculator, you're going to have to show me what you get.
I guess.
Get something to look like this. What you got? Now, let's go ahead. That's what I got. I mean, it's what I got. So that's it. I'm going to go ahead and write this equation and see if the equation matches that picture. All right, so any ideas how we might go about writing a Cartesian equation? In other words, getting rid of the t's like you did over here. Those are a little bit different. What might we do with those? Well, isn't the top one already squared? So on top, can't I just say x over 4 equals cosine squared? It's already squared. And remember, the key to getting rid of sines and cosines is to squaring them. You can't change out sines and cosines unless they're squared. So this one, I'll divide by 3 and square. So I'll have y squared over 9 equals sine squared. Now I can add them, and what do I get? I get x over 4 plus y squared over 9 equals 1. Now that's all good, that's fine. You are done, you do not have to do another thing with this. You recognize that it has 1 square in it. And equations that have 1 squared in them graph as parabolas. Why is this parabola going sideways instead of up and down like they normally do? Because it's y that's squared. So we'll study that more in chapter 8. These are not functions, that's why we didn't talk about them before. But anything that's got 1 squared is going to be a parabola. If x is squared, it opens up or down. Like our other ones have y equals x squared, your BFF. But if y is squared, they have the same characteristics, they just open sideways. So that made sense? Good. Are the following parallel, perpendicular, or neither? This is number 18. Are the following parallel, perpendicular, or neither? All right. What do you think about the vectors in A, part A?
Perpendicular.
And why would you say that? You are correct. Why would you say that? They have, if you just examine the slope, do nothing but look at the slope. The slope of the first one is -2 over 1. The slope of the second one is 1/2. Those are negative reciprocals. Just for fun, do the dot product. What happens when you do A dot B? You get 0. That means they are indeed perpendicular, orthogonal. What about part B? Did you say neither? If you said neither, you were right. Because one slope is 4/3 and the other slope is 3/4, and those don't have a special relationship. So that's a neither. You don't get a dot product of 0, and they are not multiples. So therefore they are not perpendicular or parallel. What about the ones in C? They're parallel. Isn't P -2 times Q? And what did we say about multiples? Multiples are parallel. They're in the same direction. They're moving the same way. Or, in number C, you can look at the slopes. One slope is 6 over -2. The other slope is -3 over 1. Those are the same number. Same slope means parallel. Oh my gosh, number 19 for like the 12th time today. Find the measure of the angle between these two vectors. Here we go. Our vectors are 1, 2, and -3, 5. All right, we need to find the angle between those. All right, so what do we need? Dot product, all right? What's the dot product of those? Boys and girls, x times x, y times y, add them up.
7.
Let's engage. Yep, we get 7. So the dot product is 7. What else do I need? Magnitude of the first vector. What's the magnitude of that one? Root 5. Magnitude of the second vector. What's that one? Root 34. Times the cosine of the angle between them, which is what I'm trying to figure out. what is that, root 170? I like to go ahead and multiply those together if I can. It just makes it easier when I type it in. I don't need so many parentheses. So second cosine, 7 divided by the square root of 170. Did you get 57.53 degrees?
Yeah.
Oh Lord, look at number 20. What am I doing in problem 20? Exactly the same thing. The only difference is, let's see, I'm finding angle A. They didn't give me the vectors. I have to figure those out first. If I am going to find angle A, then I am looking for the angle formed by what vectors? AB and AC. So this is exactly the same as this problem, except you got to figure out what your vectors are first. So what's AB? A to B. 2, 1. A to C. 1, -2. Well, that's interesting. All right, how do I find the angle between these two vectors? What do I do? Dot product. What's the dot product? 0. Stop right there. If the dot product is 0, what do I know about these two vectors? They're perpendicular. The angle between them is 90 degrees. 90 degrees.
Could you just look at it and say, no, that is perpendicular? Say that it's not.
Not the way I drew it, you can't, but if you plotted those points, you could, probably. You need to have some math, though. Usually just eyeballing isn't sufficient.
Well, no, I mean with the points.
You mean with the vectors? Yeah, yes. I knew immediately when I wrote these down, I was going to get 90 degrees because that dot product, the slopes are
So you just have to
Yeah.
look
Yeah. All right, now I'm going to find the area of this triangle. Well, yeah, okay. If you're going to do 1/2 side sine, you can, but we haven't found these lengths yet, so we need to find these magnitudes if we're going to do that. So what is the magnitude of this vector? Root 5. What's the magnitude of this vector? Okay, so what's the area of the triangle? 1/2 root 5 times root 5 times sine 90. And I think that's just going to be 2.5. Double check that. I think it's just 2.5.
What's your little determinant thing?
My little determinant thing would be -4. Take the commas out. -4 minus 1 divided by 2. So 5/2, 2.5. It's not my little thing. I'd love to take credit for it, but it's not mine. All right. Okay, we just did a ton of review. So we have practiced everything. Huh? Yeah. Yes. Step out. We need to decide something now, though. Okay. So I don't care which way it goes. We are done reviewing in class. There will be no more in-class reviewing. We just did a whole request. So you will do the other one. We are ready.